All right, welcome to another video in the wonderful series of Algebra 1 by Mr. Thompson. I will stop pausing awkwardly now. So, as always, before we start, let's go over some notes that you should be familiar with before getting into the lesson. So, basic square roots. Before we start, a fun little exercise. It's not really fun, but it's an exercise nonetheless. What's the opposite, unrelated, what's the opposite of addition? Subtraction. What's the opposite of multiplication? Division. What's the opposite of squaring something? Square rooting something. So keep that in mind. The opposite of squaring is square rooting. So basic square roots. You should be familiar with these, but let's recap. The square root of 4 is 2. The square root of 16 is 4, and so on and so forth. What times itself is whatever you're trying to find. What times itself is 4? 2. 2 times itself, 2 times 2 is 4. What times itself is radical 16, or square root 16? Well, 4 times itself, 4 times 4 is 16. Okay, so that's kind of just a basic review of what square roots are. But let's see what they actually mean and learn how to break them down. Now, again, most of you are already familiar with this. If you have no idea how to do this, you are absolutely fine. Okay, what do square roots actually mean? Well, on all of these radical symbols, right, you have an imaginary 2. And it's not really imaginary, invisible 2, I guess I should say. Just like when we write x's, when we have just one x, we don't necessarily need to write the 1. When we have a basic radical or a square root, we don't need to write that 2. But that 2 is important to note for a specific reason, right? So if I were to find the square root of something that is not perfect, like these, what do? Well, you break your number as much as possible. So 8 can be broken into 4 times 2. 2 is by itself now, and 4 can be broken into 2 and 2. So I circled it. And then why does this 2 mean anything to you? Well, what this actually means is you're taking that many numbers per group and taking them out of the radical sign. You're taking them out. So I have a 2 here. I have 3 2's, so I can take a group of 2, smash them together, and bring 1 out. So if I smash those and turn it into this, I only have that 1 2 left, so that remains. So the square root of 8 is 2 radical 2. So again, I know it's a whole lesson in one little example, so just let that sit for a minute. Once we go through a few of these problems, it should make more sense. If not, feel free to message me and I will go further in depth in this specific concept. Okay, but we also need to cover what's the difference between rational versus irrational. Now, you should have covered this in a few different lessons throughout your schooling. Okay, you should have hit this in 8th grade. Probably you should have hit this in 7th grade. If you've never hit this, it's not a big deal. Rational, you know, for the most part, rational numbers are just whole numbers. Irrational numbers are things that go on forever. Think pi, right? That's a really famous one. 3.1415, whatever. It goes on and on and on and on and on and on. Very, very boring, tedious stuff. So what's some examples of rational? These ones, right? 4, the square root of 4 is 2. 2 is a normal rational number. Square root of 64 is 8. Just a simple plain whole number. Square root of 100 is 10. Again, simple number. Those are all rationals. Now, if I go into and find the square root of 2, and you can use a calculator to understand these a little bit better, right? The square root of 2, if you type it into the calculator, it's 1.414213, goes on forever. Square root of 3, 1.73205, blah, 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 blah. Radical 8 is 2 times radical 2, or 2.828427, goes on forever. Notice, they keep going on forever. They're not repeating, they're just going on forever in random numbers. Okay, those are irrationals. Those are examples of irrational numbers. Now, a little foreshadowing here. Do you see any pluses or minuses out front of here? No. So when I explained rational and irrational, do you think it matters whether the number is positive or negative? No. It does not matter whether it's positive or negative. What matters is whether it just goes on a bunch of gibberish forever, non-repeating forever. Plussing and minusing does not mean anything for rational and irrational. Now, I just mentioned plus or minus, plus or minus, plus or minus. You're going to see a new symbol. You're going to see this symbol, plus or minus. What is this plus or minus business? Plus or minus literally means plus or minus. It just means, hey, I'm lazy. I don't want to write out two numbers. I'm just going to do plus and minus at the same time. So it's just the positive and the negative version of the answer. So if I wanted to find the square root of 49, but I wanted the positive and the negative version of it, I could write plus or minus 7, or I could write plus 7 and minus 7. So it's a quicker way of writing those two things in one go, right? So an example of that would be this or that. Okay, I hope that was clear. Now let's get on to the lessons and have this make a little bit more sense. So if we look at question number 1, oh hey look, it's almost the exact example I put on the notes. So plus the square root of 49. So it wants the positive value of the square root of 49. So what times itself is 49? Now, most of you should memorize these or have them memorized. If you don't, it's okay. You can use your tree, right? So the only numbers that I could think of that went into 49 was 7 and 7. How many 7s do we see? 2. So we're going to take 2, smash them together, and bring 1 out. And there's our solution. Same thing with number 2. We want the plus or minus version of radical 36. So again, plus or minus, what should our answer be? Our answer should also be plus or minus. Now, 36, if you don't already know what the square root of 36 is, that's fine. Break it to what you know. So I broke it to 3 and 12. 3 times 12 is 36, right? And I can't break 3 any further. So then I go to 12, and I break 12, 2 and 6. And then I break 6, 2 and 3. And then I circled all of the smallest numbers that I could have. Once I broke these numbers, they do not matter anymore, right? So don't worry about them. Now, as we go, how many 2s do I have? I have 2 of them right here. So I can pull out 2. Take 2 of them, smash them together, and bring out 1. How many 3s do I have? 1 and 2. Perfect. So take your 2 3s, smash them together, and bring 1 out. Now, since we brought them out, you need to multiply them. Again, where did this plus or minus come from? The beginning. Drop it down again. 2 times 3 is 6. Now you might be wondering, why, Thompson, did you draw such an ugly equal sign? And it was specifically to bother you. I actually just wanted my equal signs to line up, and I write in pen, so yeah, deal with it. Going on to number 3. I want the negative radical, or the negative square root of 121. So again, the negative, just like the plus or minus, what did we do? We brought it right to the answer. So what am I going to do? Bring it right to the answer. 121, how do we break that? Well, I can break it to 11 and 11. Here is 2 of them, right? So cross them out, smash the 2 together, and bring 1 out. So what is my answer? Negative 11. Okay, hopefully those are straightforward. Moving on to number 4. Oh no, a fraction. Ah, no, please stop. Actually, don't worry about it. It's a lot easier than it sounds, and we're not actually dealing with fractions specifically in this case. So this plus just means we want the positive version, so I'm bringing the positive version out. So as we go, when you see a big radical, giant radical like this, covering both the top and the bottom of a fraction, the numerator and denominator, you can split it into square root of the numerator, or the top, and square root of the denominator, or the bottom. So I like seeing it this way. It's a little bit easier for my brain. If you can do it without that step, absolutely fine. You're just taking the square root of the top and the square root of the bottom separately. So what is the square root of 1? 1 times 1 is 1, so it is 1. What's the square root of 25? 5 times 5 is 5. What times itself is 25? 5. So hopefully you guys are getting better with your radicals, and my answer is 1/5. You can type it into Canvas like this: 1/5. That should give you the right answer. All right, now number 5. I actually like this because it gives us practice knowing what's the difference between some of the radicals. Do plus and minuses actually matter when it comes to rational, irrational, which no, it doesn't, and getting used to different numbers. So I went ahead and I broke these down for the most part already, just so to save some time. So the square root of 8, as we've done before in the notes, we break 8 into 4 and 2, we break 4 into 2 and 2, and I have 3 2's here. So since I have 3 2's, I can take a pair of them, a group of 2, smash them together, and bring 1 out. What is left? A single. So there's no pairs for it to get matched up with, so it's just by itself, so we have to leave it under the radical. Now, what is the square root of 2? Does it go on forever? Well, if we look back at our notes, the square root of 2 goes on forever. The square root of 8 goes on forever. So spoiler alert, it's going to be irrational. So the square root of 8 is irrational. Exclamation mark, because we mean business. All right. Does plus or minus matter for rational versus irrational? No. So I'm just rewriting it so you guys can get practice in seeing what it looks like. However, it does not matter in this specific problem. So 2.25, how many quarters go into $2.25? 9 of them. So I broke 25 and 9. I broke 2.25 into 25 times 9. I broke 25 into 5 times 5. And I broke 9 into 3 times 3. So I have a group of 5s that I can smash together and bring 1 out. And I have a group of 3s right here that I can smash together and bring 1 out. When you bring the numbers out, you multiply them. I did the parentheses just so it's very clear. You don't need the parentheses. I just wanted it to be clear. So 5 times 3 is 15. Now, is plus 15 a rational number? Well, is it a whole normal number? Yes. Is negative 15 a whole number? Yes. Is it rational? Yes. Okay. So then this part 2 of number 5 is rational. If I could spell it right. Rational. Now, moving on to this one. Yeah. Sloppy. Rational. So, negative. Before we do anything, our answer is going to be negative. What did I do? I broke 75. Well, how many quarters? I like using money. So how many quarters go into 75 cents? 3. So 3 times 25 is 75. 3 is by itself. 25 can get broken into 5 and 5. I have a group of 5s here. Take them, smash them together, and bring 1 out. What is left? That 3. I cannot bring it out, so I have to leave it. Do you see a whole number? Do you see a normal whole number? No. I see negative 5, radical 3. That extra radical right there, that lets me know it's irrational. Since I could not break it to a normal number, it is going to be irrational. Are all square roots irrational? No, because we were able to break some of them and make them rational. This one, on the other hand, we still are left with a little radical. So no, this is going to be irrational. And finally, we go into this fraction. So I have the square root of 1/4. Now looking back to this problem, fractions weren't a big deal. We took the square root of the top, we took the square root of the bottom, and we got our answer, right? So that is a smudge, by the way. I just figured that out. So here we go. We have radical 1/4, or radical 1 over radical 4. So what is the square root of 1? 1. And what is the square root of 4 right here? Well, the square root of 4 is 2. So this gets broken into 2. Now, 1/2. Is that a whole number? No. So you might be thinking, is this irrational? Well, here's the key. Going back to the notes, I said something very subtle, but over and over again. Did these go on forever and ever? Yes, the dot dot dots, right? What is 1/2 as a decimal? It is going to be 0.5. Does this go on forever? No, it stops. It stops, and it's pretty nice. 0.5 is not that hard to deal with, right? So that is going to be rational. So a good rule of thumb for these types of problems: are you left with a small radical? Yes, then it's going to be irrational. Do you have a whole number? Then it's going to be rational. Do you have a nice fraction that you can easily put into a decimal? Then it's going to be rational. If you get a fraction that turns into something crazy, you can always type it into a calculator to see, then that will be irrational. But for the most part, nice fractions will be rational. All right. Moving on to the next problem. Problem number 6. Now, I really like number 6. Number 6 is something that everyone really should have a basic understanding of. So what I did is I went through, it tells us between what two consecutive integers is negative radical 105. So what are consecutive integers? Consecutive integers are two whole numbers that go one right after the other. So 1 and 2, or 6 and 7, or 33 and 34, right? Just any two numbers that go one right after the other. So this problem is saying you have the square root of 105. What two numbers does that land in between? Okay, so we need to know what two radicals or square roots that those fall between that are perfect, that we know right off the bat. So what I did is I did my little thought bubble, and I went through all of the perfect squares. So 1 squared is 1, 2 squared is 4, 3 squared is 9, so on and so forth. What we're looking for is two numbers outside of that, one before, one after. So I went until I had one before, 100, and I need one after. So what's after 105? The next number after 105 is 121 if we're going by squares. So 121. So I know the radical 105 is in between radical 100 and radical 121. So what are these consecutive numbers? The square root of 100 is 10. The square root of 121 is 11. So this has to fall in between those two consecutive numbers. Now, since this is a negative, these have to be negative. If this was positive, those would be positive. So again, we're done. We're just selecting two answers, -10 and -11. If we were to estimate, which we have to do a fancier version of that on the next and last problem of this lesson, we would have to estimate what this number would be. Well, what do you guys think this would be? So it lands in between -10 and -11. We've already established that. It has to be in between those numbers. Thompson, what is in between those numbers? Well, we have 10.1, 10.2, 10.3, 10.4, so on and so forth, right? We even have -10.23876. We have every number with decimals that land in between these two integers. So if I were to estimate, I would say this is closer to this. So what I would do is say, you know what? This radical is going to be approximately -10 point something closer to 10 than 11. I would say 2. Again, we're estimating. We're doing educated guesses here. I'm saying this lands in between those two numbers, and it's closer to 10 than it is 11. So if you were to type that into a calculator, would you get that answer? Well, luckily I have a calculator right here, so why don't we find out? So if I were to type in 105, make it negative, well, let's just do 105, and then take the square root first, and then make it negative, we would see that it would be -10.2469. So -10.2. I literally have never plugged this into a calculator. I've just been teaching math for a little while. You just estimate, you get close. Again, for number 6, those are your answers. This is a benefit. This is a nice concept to know, though, which you will have to apply in this problem. So let's move on to number 7. Number 7 was a little bit difficult to understand while reading just because it goes back to an example problem. So it says, using the formula from the application example, and then it gives you this formula, suppose x is 10 feet. So right off the bat, I wrote x is going to be 10. How long is the diagonal cross of the field? Okay, using this formula, that's how we're going to figure that out. From the example problem, or underneath the problem it says reminder, y is 3 times the length of x, or y is 3x. So what is x? 10. Plug that in. Y equals 3 times 10. Y is 30. So I already know what x is. They gave it to me. And they subtly gave me y is 30 as well. So all we need to do is plug it in and solve. So I took x and I plugged in 10. I took y and I plugged in 30. And now I'm just simplifying. 10 squared is 100. 30 squared is 900. 3 times 3 is 9. 10 times 10 is 100. 900. Okay, if you're trying to do mental math. 100 plus 900 is 1,000. And then we break it. Again, not an addition, we're breaking with multiplication. So the easiest way for me to see was 10 and 100. So I broke it 10, 100, broke my 10 into 5 and 2. Then I went over to this 100 and I went 10 times 10. And then I broke this 10 into 5 and 2, 5 and 2. So how many groups of 5s do I have? I have 1, 2, 3 5s. So I can only take out groups of 2. So I took these two, smashed them together, and brought 1 out. Similarly, I have 3 2s. So I took a pair of them, smashed them together, and brought 1 out. What is left under the radical? 5 times 2. So I left that under the radical. Now we simplify. 5 times 2 is 10. 5 times 2 is 10, so 10 radical 10. And normally we would be done. However, it doesn't want us to have our answer in radical. It wants us to round it. When it says round, we need to turn that into a decimal and multiply. So we need to know what the square root of 10 really is. So I found that the square root of 10 was about 3.16. How did I get that? Same thing I did up here. Okay. I knew 3 squared was 9, or the square root of 9 is 3. I know that the square root of 10 is a little bit bigger than 3. So again, it lands in between, 10 lands in between 9 and 16, so it's going to land in between 3 and 4. And I know that it is closer to 3 than it is 4, because it's closer to 9 than it is 16. So I use my approximate squiggle equal sign. Literally, you don't have to worry about this equal sign. It just means approximate. It means you rounded. Okay. So I knew it was going to be closer to 3 than it was 4. So I said, you know what, 3.16. This one I actually did type into the calculator because originally I just typed in 3.1 and I got the answer incorrect. So at this point, feel free to use a calculator. At this point, feel free to use a calculator. But I want you guys to get used to understanding what radicals actually mean and how to estimate them. So if we were to estimate radical 10, I would get 3.16. 10 times 3.16, you just move the decimal over, and we get 31.6. Okay, so again, these problems can get a little tricky. If you get to here, you did everything correct. This part is more or less rounding and estimating. So be careful with this, okay? Try it on your own, use a calculator to check, and then go on from there. So again, if you have any issues, I'll bring the notes back right now. If you have any issues, please feel free to email me or send me a message on Aries or comment below, and I will get back to you or follow through with one of these in more detail. I really think this is a lesson that you have to spend more time doing practice problems to fully understand. So go through your practice, try your best, and I think you will do wonderful. Have a great day. Thanks for watching.